Okay, let's begin. So last time we talked about how to use the point on the terminal side of an angle which is not the point of intersection with the unit circle to define the sine, cosine of the alpha, angle alpha. So we just take the terminal side in the quadrant 2 as one example. And say we have this point x and y, and then we know, say this is alpha, say this is a point of the intersection with the unit circle x1 and y1. So we know we have the x and x1, both are negative, right? We have the x and the x1 in this quadrant 2 less than 0. And we have the such a trigonometric ratio relation. Say we have the absolute value of x1 over the absolute value of x equal to 1 over r. Here this r is the distance between this point P and the origin O. So that is square root of x squared plus y squared. So from here, when we try to remove this absolute value bars, we know this absolute value of x1 is just equal to the negative x1. Then the absolute value of the x is equal to the negative x. So you may just replace this by the negative x1 and replace this by the negative x. And then you get the negative x1 over the negative x equal to 1 over r. So this just implies you have the x1 over the x equal to 1 over r. And this equality holds for any quadrant, not only for this quadrant 2. So this argument can apply to the other quadrant. So you always have this relationship. Then from here, you know the x1, which is the x coordinate of the point of intersection with the unit circle, equal to x over r. And in this way, we know this xy is the cosine alpha, right? So you have the cosine alpha equal to x1, and then this is equal to x of r. So in this way, we just express the cosine of this alpha in terms of the coordinates of the point which is not the point of intersection with the unit circle. Now, today we continue to talk about the right triangles. So, we first have a right triangle like this, with acute angle alpha, and the adjacent side, the length of the adjacent side is x. The length of the side opposite this angle alpha is y. And the length of the hypotenuse is r. And then we position this right triangle in a rectangular plane with the vertex of this acute angle at the origin and this adjacent side at the positive x-axis. So after we position this triangle in such a rectangular plane, then we know the coordinates of this point is the x and y, right? See this x, this length, and this y, this length. So the coordinates of this point is x and y. Then in this way, we can use the length of these two necks to express the sine, cosine, and tangent of this alpha. For example, sine alpha, we know that is equal to the y over r, right? So you get the sine of alpha equal to y over r. And then cosine alpha by the trigonometric ratio theorem, you know that is equal to x over r. So you have the cosine alpha equal to x over r. And the tangent alpha, that is equal to this y over x, right? So let me call this, let me use the OPP for this opposite, and let me use the ADJ for this adjacent, and let me use the HYP for this hypotenuse. Then we can express the sine alpha as the y, that is the opposite, over the r, that is hypotenuse, and cosine alpha, that is equal to adjacent, over r, that is hypotenuse, and tangent alpha, that is equal to the opposite over the adjacent. So this guy is equal to opposite over adjacent. And similarly, we can get the other three trigonometric functions. So we have the cotangent, which is equal to x over y. So that is equal to adjacent over the opposite. And we have the second alpha, this cotangent alpha. We have the second alpha, which is equal to the r over x. So that is equal to hypotenuse over adjacent, right? And then we have the cosecant alpha, which is equal to r over y. So this is equal to the hypotenuse over the opposite. So use this to help you to memorize the 6 trigonometric function values of an acute angle in a right triangle. Okay, now let's look at the page 490, example 2. Try this part. So we have a right triangle which has the necks with the length 2 and 4. Then we need to find the sine alpha, cosine alpha, and the tangent alpha if the alpha is the angle opposite the side of the length 4. So let's first sketch this right triangle, and then we use the definition to find these 3 trigonometric function values of alpha. Let's go to the whiteboard.